So imagine a cube 6 miles across, deep and high.
Damn.
And that's how much lava came out.
Something strange is brewing beneath Yellowstone. A massive dome-shaped uplift is rising from the iconic caldera, baffling scientists. Bizarre wildlife behavior hints at unseen forces reshaping their environment. And deep underground, a vast magma chamber appears to be recharging, its molten fury inching closer to eruption. As unnerving signs compound daily, calls grow to evacuate the park before Yellowstone's slumbering giant reawakens with apocalyptic force. The clock is ticking on a potential civilizational catastrophe. Let's investigate. 1. Geological overview of Yellowstone supervolcano. In the heart of the American West, a sleeping giant lurks beneath the breathtaking vistas of Yellowstone National Park, one whose awakening could alter the face of the Earth. The Yellowstone supervolcano, a vast and complex volcanic system, rests quietly for now, but its history speaks of a turbulent and explosive past that has shaped not just the local landscape, but has had far-reaching effects across the globe. But what exactly makes Yellowstone a supervolcano? And more ominously, could today's seemingly tranquil landscape once again unleash its fury upon the world? This term refers to the type and scale of eruptions it has produced throughout its history, characterized by massive ejections of magma. Unlike typical volcanoes that form conical mountains punctuated by a central vent, the Yellowstone supervolcano is a caldera. A caldera is essentially a large depression formed when a magma chamber empties and collapses under the weight of the earth above it. This supervolcano's caldera spans approximately 30 by 45 miles, a testament to the immense underground forces at play. To understand the might of Yellowstone, one must delve into its volcanic structure and the cataclysmic events that have sculpted its present form. The supervolcano has had 3 major eruptions in the past 2.1 million years, each reshaping the landscape on a monumental scale. The first of these eruptions occurred around 2.1 million years ago and formed what is known as the Huckleberry Ridge Tuff. This event was so massive that it left a caldera over 60 miles across and spewed enough volcanic material to fill the Grand Canyon half a dozen times over. Why should we be concerned about an event so distant in the past? Well, the history of a volcano is the best predictor of its future behavior. The second eruption, which occurred about 1.3 million years ago, formed the Island Park caldera and the Mesa Falls Tuff. Like its predecessor, this eruption was colossal, dispersing vast quantities of ash and debris across much of the United States. The most recent of these eruptions, and perhaps the most famous, is the Lava Creek eruption approximately 640,000 years ago. This event created the current Yellowstone caldera and ejected about 240 cubic miles of material. The ash from this eruption covered all of the western U.S., extending into Canada and farther south. But what does this scale of eruption mean for the world today? If Yellowstone were to erupt with similar force in the present day, the consequences would be catastrophic. The ash ejected into the atmosphere could lower global temperatures, disrupt agriculture, and affect air quality worldwide. It's a chilling thought. A volcano that has the power to disrupt modern civilization as we know it. And with strange wildlife activity hinting at potential imminent eruption, one has to wonder, are these the first ominous signs of an apocalyptic event in the making? With the 2024 U.S. elections approaching, the management and monitoring of such a monumental natural threat could become a pivotal issue. Candidates may be pressed on their policies for national safety, environmental management, and disaster preparedness, issues that the Yellowstone supervolcano directly impacts. How will they ensure that the necessary resources and attention are dedicated to this ticking geologic time bomb? Inside Yellowstone's caldera today, the evidence of its fiery past and potentially explosive future is visible in the landscape. The caldera floor is dotted with geothermal features, over 10,000 hot springs, mud pots, fumaroles, and geysers, including the famous Old Faithful. These features are driven by the heat of the still active magma chamber below, which stretches for miles beneath the park's surface. But what might trigger another super eruption? The magma chamber beneath Yellowstone is still very much active, as evidenced by the frequent earthquakes and ground deformations observed in the region. These signs are closely monitored by the Yellowstone Volcano Observatory, which uses a network of seismographs, GPS units, and other sensors to track the slightest changes in geological activity. This monitoring helps scientists predict and prepare for possible future eruptions, though predicting the exact timing of such events remains a significant challenge. While Yellowstone's serene beauty and geothermal wonders attract millions of visitors each year, beneath the surface, the forces of creation and destruction are in a delicate balance, with the power to reshape our world. It is possible that these forces are once again gathering strength even as we speak, preparing for an event that could darken skies across continents. 2. Recent seismic activity. In the shadowy depths beneath Yellowstone National Park, the Earth trembles with a quiet yet unnerving frequency. Recently, the U.S. Geological Survey reported a troubling pattern of seismic activity within this renowned supervolcano. Over the past months, hundreds of earthquakes have gently rattled the region, painting a picture of a landscape that is anything but dormant. During March 2024 alone, the University of Utah seismograph stations detected no less than 96 earthquakes in the area surrounding Yellowstone, marked by 2 alarming swarms that have drawn the attention of both scientists and the public, potentially teasing deeper stirrings within the Earth. One might ask, why does this matter? Consider the clusters of tremors. The first swarm occurred from March 4th to 6th, east-northeast of West Yellowstone, Montana, consisting of 24 tremors, with the strongest peaking at a magnitude of 1.3. A second series unfolded from March 14th to 15, approximately 11 miles west of Old Faithful, comprising 12 earthquakes, the largest of which reached a magnitude of 1.5. Such swarms are often a precursor to changes within a volcano's magma chambers, signaling that magma is on the move, reshaping the subterranean landscape in ways unseen from the surface. But the mystery deepens. Yellowstone is no stranger to seismic activity, experiencing anywhere between 1,500 to 2,500 earthquakes every year. Most of these tremors are minor, often going unnoticed, yet they play a crucial role in revealing the dynamic geological processes at play beneath the park's surface. Keeping in mind the history of earthquakes in this region, the recent activity at Yellowstone has been both frequent and intensely clustered. Each tremor, each rumble beneath the Earth's crust could be straining against the confines of the massive magma chamber below, accumulating energy that could, very soon, lead to an eruption. What do these patterns typically indicate about the state of the volcano? Earthquakes can result from the shifting of magma, the movement of hydrothermal fluids, or tectonic shifts within the Earth's crust. The frequent occurrence of these tremors, especially in swarms, helps scientists gauge the internal pressures building up within the magma chambers that fuel the park's famous geysers and hot springs. These revelations remind us that the Earth beneath our feet is alive, and that understanding its language is key to safeguarding our future against the potent forces of nature. 3. Reports of a dome-shaped uplift. Amidst a backdrop of recent unsettling seismic activity, another notable and ominous development at Yellowstone National Park demands our attention: the alarming rise of a dome-shaped uplift within its vast caldera. This recent revelation, intertwined with earthquake swarms, casts a shadow of foreboding over the region, suggesting that the supervolcano may be recharging for another colossal eruption. Recent measurements by the Yellowstone Volcano Observatory have highlighted various patterns of deformation across the Yellowstone caldera. Ground deformation, including both uplift and subsidence, is a regular feature here, driven by the movements of magma, water, and gases beneath the surface. Since 2015, the general trend has involved subsidence with brief periods of uplift influenced by seasonal factors such as snowmelt. Specifically, GPS data from around the park has documented a subsidence of approximately 1 inch since the end of September. These measurements, captured by a network of GPS stations, provide critical insights into the minute yet significant vertical and horizontal movements of the ground, which can indicate deeper changes within the magma chambers below the surface. Now, the unsettling occurrence of the dome-shaped uplift, first detected and now continuously monitored using advanced geotechnical methods, has been a focal point for scientists at the Yellowstone Volcano Observatory. Using INSAR and GPS technologies, researchers are meticulously mapping the subtle yet significant movements of the Earth's surface across this geologically active area. INSAR, which stands for Interferometric Synthetic Aperture Radar, is an advanced satellite-based technology that provides detailed, albeit less frequent, wide-area observations of ground deformations. This technology has captured significant ground movements, notably a dome-shaped uplift in recent years that suggests a fluid intrusion beneath the surface, possibly magma making its way into the volcanic system's intricate network of chambers. On the ground, GPS offers a more granular, continuous data stream, pinpointing the slightest shifts in the landscape. The network of GPS stations strategically placed around the park has recorded distinct patterns of uplift and subsidence. The most recent data highlight an upward movement in specific areas of the caldera, notably around known resurgent domes, aligning with the regions where seismic activity has been notably frequent and intense. This pattern of ground deformation is not isolated. Similar phenomena have been observed in other major caldera systems around the world, though Yellowstone's activity is unique due to its scale and the potential implications of its reawakening. For instance, the Campi Flegrei caldera near Naples, Italy, has shown even more dramatic rises and falls, but the context and scale at Yellowstone, covering a vast area with a thick crust capable of massive magmatic intrusions, makes it particularly noteworthy. The interplay between rising magma and the overlying crust not only forms the physical bulges and depressions in the landscape, but also contributes to the seismic swarms. These tremors are likely caused by magma forcing pathways through the rock, altering pressures and creating fractures that manifest as earthquakes. This scenario paints a troubling picture of a supervolcano straining against its bounds, possibly heralding an eruption that could have global consequences. As ominous as this sounds, the real-time monitoring and data analysis conducted by the Yellowstone Volcano Observatory provide invaluable insights into the volcano's behavior. This ongoing surveillance is crucial not only for predicting potential eruptions, but also for understanding the broader implications of such significant geologic activity. While the beauty of the park continues to draw visitors, the ground beneath their feet tells a story of a restless giant, hinting at its destructive potential through the very land that enthralls and enchants us all. 4. Strange wildlife activity around Yellowstone. The intrigue surrounding Yellowstone's natural and geological activity only deepens as researchers delve into the mysteries of the park's ecosystem. Recent observations in Yellowstone National Park have revealed some enigmatic changes in wildlife behavior that might be linked to subterranean geological activities. These anomalies provide a fascinating glimpse into how animals might be reacting to underground changes that humans can barely detect. Grizzly bears in Yellowstone, for instance, have shown unusual early activity patterns this season. Typically emerging from hibernation in sync with available food sources like bison carcasses left over from winter, the grizzlies' early appearance and their aggressive feeding suggest an adaptation to changing conditions in their environment. Yet what triggers this behavioral shift remains a puzzle. Is it the rumblings of the earth beneath their paws, signaling changes in food availability, or perhaps a primal response to unseen forces shaping their habitat? Researchers suspect it could indicate shifts in the ecosystem possibly triggered by geothermal activity affecting the availability or timing of food sources. Meanwhile, the enigmatic influence of Toxoplasma gondii on Yellowstone's wolves adds another layer of complexity to the ecosystem's dynamics. This parasite, which can alter the behavior of its hosts to increase risk-taking, has been linked to significant changes in wolf dynamics within the park. Infected wolves may display unusually bold or aggressive behaviors, which could affect pack structure and interactions with other wildlife. These behavioral changes are particularly interesting, as they might be responses to environmental stressors, which could include geological changes beneath the park. Even the mighty bison, Icons of the American West are not immune to the whispers of change echoing beneath Yellowstone's surface. Bison have been observed breaking young aspen saplings, an action not directly linked to feeding but possibly to displays of dominance or aggression. This activity hinders the regeneration of aspen forests, crucial for the ecosystem's balance. The aggressive behaviors in bison might be exacerbated by stress from environmental pressures, including those from underground activities that could affect the landscape or water sources they depend on. Could these displays be a primal response to shifting territories, a warning sign of deeper unrest lurking in the park's geothermal depths? These behavioral shifts in key Yellowstone species hint at a deeper connection to the park's volcanic nature. Animals, with their keen senses and instinctual responses, often serve as the vanguard of environmental change, offering researchers invaluable clues to the subtle shifts occurring beneath the Earth's surface. Armed with this knowledge, researchers can refine their monitoring techniques, deploying advanced tools to track animal movements and behaviors with unprecedented precision. By integrating this data with geological surveys and satellite imagery, they can construct comprehensive models to forecast volcanic activity and mitigate potential risks to both wildlife and human populations. As Yellowstone's inhabitants navigate the ever-shifting landscape, they provide invaluable lessons in survival that resonate far beyond the boundaries of the park, drawing us ever closer to unlocking the secrets of our planet's turbulent past and uncertain future. 5. State of the magma chamber. Now, scientific investigations have unearthed yet another startling revelation about the supervolcano's magma chamber. It contains more liquid magma than previously recognized. But what does this mean for the potential of a catastrophic eruption? Advances in geophysical techniques have allowed scientists to peer deeper and more accurately into the Earth's crust than ever before. Utilizing technologies such as seismic tomography, which works much like a CT scan but for the Earth, researchers have been able to delineate the magma chambers beneath Yellowstone with unprecedented clarity. These studies have shown not just one, but two large magma chambers. The upper chamber, already known, is sizable, but it's the discovery of the even larger, deeper chamber that has shifted scientific perspectives. This deeper chamber, filled with a significant volume of molten rock, lies beneath the already daunting upper chamber, forming a colossal reservoir of molten material. The implications of this finding are profound. The presence of more liquid magma suggests that the supervolcano has a greater capacity to feed an eruption than previously thought. But does this mean an eruption is imminent? Not necessarily. While the volume of magma is a crucial factor in volcanic activity, the eruption risk is also influenced by the magma's viscosity and the integrity of the rock above it, which acts as a seal keeping the molten rock below ground. The more liquid the magma, the easier it is for it to escape through cracks and fissures in the Earth's surface. However, for an eruption to occur, sufficient pressure must build within the magma chamber to fracture this rocky seal. Current studies suggest that while the amount of magma is substantial, the conditions necessary for such pressure buildup are not currently met. The rock cap over the magma chambers, despite being under immense pressure, remains intact and stable for now. Despite the use of advanced monitoring techniques, predicting the exact timing of a volcanic eruption remains one of the most formidable challenges in Earth science. The systems at play are complex and influenced by myriad factors that can change over time. With this context in mind, each piece of data helps to better predict and prepare for a potential event that, while unlikely in the immediate future, would be unparalleled in its impact. 6. Global consequences of a potential eruption. Imagine a world blanketed by thick clouds of volcanic ash, where sunlight struggles to pierce a haze that looms over vast stretches of the Earth. This is not the plot of a dystopian novel, but a plausible scenario if the Yellowstone supervolcano were to erupt. Such an eruption could unleash catastrophic effects not only locally but across the globe, affecting everything from the climate to agriculture and transportation networks. The eruption of a supervolcano like Yellowstone is characterized by the expulsion of massive quantities of ash and sulfur dioxide into the atmosphere. Ash clouds, potentially covering vast areas of North America, could extend thousands of miles from the eruption site. These clouds would not only block sunlight but also pose severe hazards to air travel by clogging aircraft engines. The eruption of Eyjafjallajökull in Iceland in 2010, which was relatively small by supervolcanic standards, led to the largest air traffic shutdown since World War II. Now, imagine the scale of disruption if the much larger Yellowstone volcano were to erupt. But why should someone living thousands of miles away from Yellowstone care about its eruption? The reason is the phenomenon known as a volcanic winter. Volcanic winters occur when the sulfur dioxide released during an eruption forms sulfate aerosols in the atmosphere. These aerosols reflect sunlight back into space, significantly cooling the Earth's surface. Following the 1815 eruption of Mount Tambora in Indonesia, the largest eruption in recorded history, the subsequent year, 1816, was dubbed the Year Without a Summer, with widespread crop failures and food shortages across the northern hemisphere. A Yellowstone eruption could lead to even more dramatic temperature drops given the larger volume of sulfur dioxide it could release. The impacts on global agriculture would be severe and multifaceted. First, the drop in temperatures would shorten growing seasons, reducing crop yields. Regions dependent on rain-fed agriculture might experience failures due to the disruption of monsoon patterns or the outright lack of sufficient sunlight for photosynthesis. The ash fallout itself could bury crops under a layer of particulate matter, as well as contaminate water sources vital for irrigation. Global transportation networks would face unprecedented challenges. Major airports could be shut down for weeks or even months, depending on the spread and density of the ash cloud. Highways and railways could be buried or made slippery by ash, disrupting ground transportation and delivery of goods. The maritime industry would not be immune either, as volcanic ash could affect shipping lanes and port operations. The potential for a chain reaction of economic consequences is high. With agriculture staggered and supply chains disrupted, food scarcity could become a real issue, driving up prices and causing economic instability. Energy production, particularly in regions reliant on solar power, could also be heavily impacted by the persistent ash clouds blocking sunlight. Thus, while the Yellowstone supervolcano lies dormant, the threat it poses remains a vivid reminder of our planet's dynamic nature. Its eruption could be a pivotal moment in modern history, testing our resilience and adaptability in the face of natural disasters. For scientists, policymakers, and the global community, understanding and preparing for this possibility is not just about addressing a distant hypothetical, but about ensuring that humanity can withstand and adapt to some of the most extreme challenges imaginable. 7. Impact on the 2024 American elections. In the context of the 2024 U.S. elections, the potential threat of a Yellowstone supervolcano eruption could profoundly influence election strategies and the national discourse on disaster preparedness. The imminent risk posed by such a geological event would necessitate a robust response from political candidates, affecting their campaign priorities and the issues they choose to highlight. The looming possibility of a supervolcano eruption brings disaster preparedness sharply into focus, pushing candidates to address how they would enhance national safety measures and response strategies. Policies might include increasing funding for geological monitoring and advancing emergency management systems to handle the massive evacuations and long-term disruptions that would follow an eruption. Discussions would likely revolve around strengthening the infrastructure to withstand volcanic ash fallout, which could severely impact air quality, water sources, and agriculture across the country. Candidates may propose enhancing the capabilities of agencies like FEMA and the U.S. Geological Survey, underscoring the importance of scientific research in monitoring and predicting volcanic activity. The recent FEMA National Preparedness Report emphasizes the need for improved community-level risk management and better adoption of building codes to mitigate disaster impacts, which could become key points in policy debates. Moreover, in response to heightened disaster risks, including those from volcanoes, there has been a call for more effective national preparedness frameworks. This might include revising the Stafford Act, which governs federal natural disaster response, to ensure more equitable and efficient disaster relief and recovery processes. Discussions could extend to how to secure critical infrastructure and safeguard electoral integrity in the face of such widespread natural threats, aligning with ongoing efforts to bolster cyber and physical security around national elections. Election candidates would need to articulate clear and convincing plans for enhancing the resilience of communities against not just volcanic eruptions, but a range of natural disasters increasingly exacerbated by climate change. This involves not only immediate crisis management, but also long-term strategies to reduce vulnerability and ensure sustainable recovery efforts. The debate over these policies could be pivotal in the elections, with candidates being evaluated on their readiness to handle catastrophic events and their commitment to scientific and practical approaches to disaster preparedness. The readiness to handle such threats could well become a litmus test for the next leaders of the United States. 8. Lessons from other supervolcano disasters. Yellowstone, with its frequent seismic activity and expansive magma chambers, often grabs headlines. However, it's not alone in its potential for catastrophic eruption. In the heart of the North Island of New Zealand lies the TPO Volcanic Zone, a sprawling landscape dotted with geothermal wonders. Here, the Earth's restless energy simmers just beneath the surface, creating an environment teeming with geysers, hot springs, and, ominously, supervolcanoes. Among them, Lake Taupo stands as a testament to the colossal eruptions that shaped this land millennia ago. Compared to Yellowstone, the Taupo Volcanic Zone presents a different geological setting. While both regions harbor supervolcanic systems, their underlying mechanisms differ. Yellowstone's caldera, for instance, is fueled by a mantle plume, a column of hot rock rising from deep within the Earth. In contrast, the Taupo Volcanic Zone's volcanic activity stems from the complex interactions between the Pacific and Australian tectonic plates known as subduction. This distinction in geological drivers manifests in the nature of eruptions. Yellowstone's eruptions, although infrequent on a human timescale, are characterized by their colossal magnitude, capable of ejecting hundreds of cubic kilometers of ash and debris into the atmosphere. Conversely, the Taupo Volcanic Zone experiences more frequent, albeit smaller, eruptions, with notable events such as the Orowanui eruption approximately 26,500 years ago. Despite their differences, both Yellowstone and the Taupo Volcanic Zone share a common thread: the potential for cataclysmic eruptions that could have far-reaching consequences for the surrounding regions and beyond. Venturing further afield, we encounter the Indonesian archipelago, a land shaped by the relentless forces of volcanic activity. Here, the Pacific Ring of Fire traces its fiery path, marking the convergence of several tectonic plates. Among the archipelago's many volcanoes, none evoke as much awe and trepidation as Mount Tambora. In 1815, Mount Tambora unleashed its fury in what is now known as the most powerful volcanic eruption in recorded history. The eruption sent shockwaves across the globe, altering weather patterns and causing the infamous year without a summer. Yet despite its devastating impact, Mount Tambora's eruption pales in comparison to the potential fury of Yellowstone's awakening. The difference lies in scale. While Mount Tambora's eruption ejected around 160 cubic kilometers of material, Yellowstone's supervolcanic eruptions dwarf even this staggering figure. The most recent major eruption at Yellowstone, occurring approximately 640,000 years ago, spewed over 2,500 cubic kilometers of volcanic ash and debris, a cataclysmic event that reshaped the landscape and left a lasting imprint on the planet. But what sets Yellowstone apart from its counterparts is not just its explosive potential, but also its unpredictability. Unlike many volcanoes that exhibit clear precursory signs of an impending eruption, Yellowstone's supervolcano remains shrouded in mystery. Its vast size and complex geological dynamics make forecasting eruptions a formidable challenge for scientists. 9. Emergency preparedness and response strategies. So, what lessons can we glean from monitoring and managing these supervolcanoes? One crucial takeaway is the importance of early warning systems and robust monitoring networks. By tracking seismic activity, ground deformations, and gas emissions, scientists can detect signs of volcanic unrest and provide timely warnings to at-risk communities. This proactive approach allows for the implementation of evacuation plans and other mitigation measures, reducing the potential impact of an eruption. Additionally, the development of comprehensive evacuation plans tailored to the specific risks posed by supervolcanic activity is crucial. These plans must account for factors such as the potential spread of volcanic ash, the formation of pyroclastic flows, and the displacement of communities within the eruption's immediate vicinity. In the case of Yellowstone, which spans multiple states and is surrounded by diverse ecosystems and infrastructure, coordination among federal, state, and local agencies is crucial. Evacuation routes, emergency shelters, and communication strategies must be carefully mapped out and regularly updated to ensure their effectiveness in the event of an eruption. Moreover, public education and outreach efforts are essential for raising awareness about volcanic hazards and informing residents about evacuation procedures and safety precautions. In addition to early warning systems, emergency response plans must include provisions for rapid deployment of resources and personnel to affected areas. This involves pre-positioning emergency supplies, medical personnel, and search and rescue teams in strategic locations to facilitate swift response and evacuation efforts. Furthermore, interagency collaboration and mutual aid agreements are essential for leveraging resources and expertise across jurisdictions and ensuring a coordinated response to large-scale disasters. Moreover, the development of robust communication channels is critical for disseminating timely information to the public and coordinating emergency response efforts. This includes leveraging traditional media, social media, and mobile technologies to reach a broad audience and provide updates on evacuation orders, shelter locations, and safety guidelines. Additionally, community engagement and involvement in emergency planning processes can enhance resilience and foster a sense of collective responsibility for disaster preparedness. Furthermore, ongoing training and exercises are essential for testing and refining emergency response plans and ensuring readiness to mobilize resources in the event of a supervolcanic eruption. This includes conducting tabletop exercises, simulation drills, and multi-agency training exercises to simulate various scenarios and identify areas for improvement. By regularly evaluating and updating emergency preparedness measures, stakeholders can enhance their capacity to effectively respond to the dynamic and unpredictable nature of volcanic hazards. Ultimately, while the prospect of a supervolcanic eruption may seem daunting, proactive emergency preparedness and response strategies can help mitigate the impact on human lives and infrastructure. By leveraging advances in monitoring technology, fostering interagency collaboration, and engaging with communities, stakeholders can work together to enhance resilience and safeguard against the devastating effects of volcanic disasters. After all, in the face of nature's fury, preparedness is our best defense. Thanks for watching another episode. Click the next video on your screen for more.